This video will introduce an exploratory data analysis tool that has the potential to help analyze find patterns on transaction data. This analyzing tool is designed and implemented to show the patterns of consumers' purchasing preference. The main result of our research work is we found that the shape of time curve can truly map into different spending patterns. Let's see the overview information about each component. Briefly, there are three main sections: configuration panel, overview panel, and more detailed information panel. Firstly, we will show the configuration panel. This panel is used to define data query and the meaning of visual variables. Basically, users need to upload the original dataset first. Currently, for the purpose of demonstration, a default dataset has been uploaded. We can use the selections to do configuration. For instance, data query includes year, month, and city fields, and the time scale selection is used to decide the time curve's level. We also can change the background color of overview panel through the type of indicators. For instance, when we choose weather as an indicator, there are three subsections can be configured: temperature, wind speed, and precipitation. After completing the configuration, we can use this tool to detect spending patterns, showing in the overview panel. Now we have chosen the day of March 2018 and set the time curve to hourly level, and the background color of overview information represents the temperature value. Here, each column stands for different merchant category. We selected the top 10 popular MCCs. Each row means different days in March 2018. As a result, each cell represents a day specifically, with information of time curve and MCC. The color of background means the average temperature value in that day. Blue means temperature below zero, and red means greater than zero. For example, in March 2018, by considering the transaction amount, the top 10 MCCs were airlines, vehicle transportation, loading, grocery, and extra. From the overview panel, we found that in the 3rd of March, there are interesting patterns in grocery shopping. Let's click the cell to see a more detailed way. The definition of time curve is a timeline is folded into itself in a way that similar time points end up being close to each other. Here, there are two time curves: spending time curve and weather time curve. Spending time curve was built by the value of transaction amount and transaction count. Weather time curve was created based on the data of precipitation, wind speed, and temperature. In the time curve, each curve has 24 points, representing 24 hours in a day. The size of time points means transaction amount, and the color represents the volume of transaction count. We can hover the point to show a more detailed information, and the annotation bar at the bottom can help us locate a specific time point quickly in case the curve becomes messy. The spatial distance between each point shows the similarity of each point. What we see from this graph is that most time points after 12 p.m. were similar to others and yield clusters. The shape of time curve shows the evolution of transaction cost for grocery, follows an alteration pattern before 12 p.m., and the changes after 12 noon are all very similar. For the weather curve, we know that on the 2nd day of March, the weather didn't change so much before noon. After 12 p.m., the temperature varies, and the greatest degree of change occurring between 1 p.m. and 2 p.m. The size of the point represents the value of precipitation, and the color represents the temperature. Since our trading data is generated in a specific formula, we can see that time curve mostly accepts a U-turn pattern when the volume and the number of transactions trend like a chi-square curve. When the trends follow a standard distribution curve like, it is most likely shows a cycle pattern. Also, we can use the overview panel to review information efficiently. For example, in 2018, March 4th, the temperature was above 0 degrees. The pattern of grocery consumption and vehicle transportation consumption were roughly the same. It might mean most people who live in this area do grocery shopping by car. When we look at the direction of columns, we can observe the different time curves with the same MCC under different weather conditions. When we identify with the direction of rows, we can observe the different time curves with the different MCC under the same weather conditions. We can also change the weather to MCC-related indicators, such as average transaction count, total transaction count. The future work of this tool is to develop different levels of time curves that enable users to do roll-up and drill-down interaction between different time curve levels. In this project, all the transaction data was based on data simulation process, and the weather data was real-world data collected by IBM. Thanks for watching.